topics is about the electric potential and potential difference. In the previous concept we learned about the electricity, right? So generally when the charges will flow means if potential difference is there, so by the time only the charges will flow. So without any potential difference, the charges won't flow from one terminal towards the another terminal. Now learn first what is meant by electric potential. So before that, we'll see an example. So here, two containers are there which are interconnected with each other. And the two container, the level of water is same. Whether there will be any transfer of water level from one container to the other container? No. There won't be any transfer of water. Reason, the difference, the level of water difference in both the container is going to be same. So that is the reason the water is not flowing from one container to the another container. Now we come for the second condition. Here also two containers are there which is interconnected and filled with water. But in one container, the level of water is high. Whereas in another container, the level of water is low. Now the water will flow from one container to another container or not? Yes, it will flow. From which end to which end it will flow means from the higher level to the lower level. That means if there is a difference in the water level only, the water will flow from one container towards the another container. Same. If you are taking the charges also, this charges also will flow only if there is the potential difference. There is the potential difference. So by using what device you are going to give the potential difference means by using a battery. So this battery only is going to maintain the potential difference. One of the important one mark question already said, name the device which helps to maintain the potential difference. Which device is going to help maintain? Battery. So this larger line will be calling it as positive and smaller line will be calling it as the negative. So once it is connected like this means what will happen? A certain amount of electric pressure will be created in the ends of the container. Sorry, the ends of the conductor. So due to the electric pressure, this electric pressure is nothing but called as the potential difference. So once this electric pressure has been given, what will happen means the charges will start to move from one end of the conductor towards the end. That means we are giving the potential difference. Once the potential difference has been given, the charges will start to move. So how we are going to define the electric potential? Electric potential is defined as the amount of work is done. So why we are using the term called as work done over here? As I said earlier, pressure. In lower class we learned about the term called as pressure. Pressure is nothing but called as a certain amount of force which is acting on a unit area. So in this specific area, we are giving the force. Once a force has been given, what will happen means the charges will start to get displaced. We all learned the product of force into displacement is nothing but called as work. That means we are doing the work. Now, for what we are doing the work? In order to move the charge. In order to move the charge. We in the sense the battery is going to do the work. So this is what we'll be calling it as electric potential. So how we are going to define electric potential? Electric potential is defined as the amount of work is done to move a charge. And here we are using the term called as against electric force. So why we are using the term called as against electric force? So let's take a condition. A conductor is there. We all know the charges will flow. What type of charges it is? Electron. So both are negatively charged particles. Whether it is like charged particle or unlike charged particle. Like charges, what will happen means they will repel each other. They will repel each other. That means this electron will move towards the left side and this electron will move towards the right side. So now what you are going to do? You are going to do some work against this electric force. Against this electric force, and you are going to push all the electrons to move in one specific direction. You are going to move the electrons in one specific direction. That means always the electron will move towards the positive terminal of the battery. So they'll be giving the question like this. They'll be giving n number of electrons will be there. And then they'll connect one end along with the positive and the other end along with the negative. And then they'll ask us to plot the direction of electron or in which direction the electrons will start to move. Either it will move towards the left side or it will move towards the right side. So based upon this diagram, the electron will move towards the left side. Electron will move towards the left side. Why? Because electron is a type of a negatively charged particle. And negatively charged particle will move towards a positive terminal. Negatively charged particle will move towards a positive terminal. Why? Because this one is unlike. Unlike charges will attract. Now, the second condition, it's like this. Look at the diagram carefully and then answer. Let's take the electrons, which is connected along with the battery. As per the given diagram, in which direction the electron will move. Either it will move towards the right side or it will move towards the left side. Towards the right side. Yeah, why? Because the positive terminal is over here. All the electrons will start to move towards the positive terminal. That means towards the right side it will move. Next, unit of electric potential. Since it is a measurable, we need the unit, and the unit of electric potential is volt. So this is the third unit what you are learning in this chapter. Already learned about charge. Another one is current. What is the third unit you are learning? Electric potential. So what is the unit of electric potential? The unit of electric potential is volt. And this one is named after the scientist Alessandro Volta. If you are remembering the name means you just write. So this one helps to boost your marks. Yeah. So what is the unit of current? The unit of current is volt and represented by the symbol V, and which is named after the scientist Alessandro Volta. So this volt we can also write it as joule per coulomb. How we wrote this one? So from the formula only alone, what is the formula to calculate electric potential? V is equal to W by Q, where V is called as electric potential, W is called as work, and the unit of work is joule, and Q is called as charge, and the unit of charge is coulomb. Yeah. So if you are going to substitute over here, instead of work you are going to write it as joule, and for charge you are going to write it as coulomb. So if you are pronouncing this one, you can say it as joule per coulomb. If you are going to write in a symbol, we can write it as J C power minus 1. So this is the other unit of electric potential. So what is the other unit of electric potential? Joule per coulomb. And how we are going to define that 1 volt? That means we are going to define the unit of voltage. Voltage or potential difference, all the meaning are going to be same. So now what is the unit of voltage? The unit of voltage is volt. So this volt we are going to define. So how we are going to define 1 volt? 1 volt is defined as 1 joule of work is done. So how much amount of work we are going to do over here? 1 joule. For what purpose we are going to do that work means in order to move the 1 coulomb of charge. So that's what we'll be calling it as 1 volt. If you're having confusion in writing this formula, yeah, what I need to write over there. First, voltage. What is the unit of voltage? Or I'll write this formula. What is the formula to calculate voltage? V is equal to W by Q. After writing this one, write all the respective units. What is the unit of voltage? Volt. What is the unit of work? Joule. What is the unit of charge? Coulomb. After writing this one, in front of all the letters, put 1. So then how we can define 1 volt is defined as 1 joule of work is done in order to move a charge of 1. All defined. 1 volt is defined as 1 joule of work is done in order to move a charge of 1. Next. How to maintain the potential difference. By using what device you are maintaining? Cell R3. So the chemical action which is taking place within the cell will generate the potential difference. So they will be asking which one is going to generate the potential difference. Which one will generate the potential difference? Either a cell or battery. And when the charges will flow means only if there is a potential difference. And then by using what device you are going to maintain this one? By using the cell or battery. Next up, how to measure the potential difference. Already learned how to measure the current. By using what device you are measuring the current? Here. The same as it is, the potential difference can be measured by using the device called as voltmeter. And what type of device it is? Voltmeter is a type of a high resistance device, whereas ammeter is of a low resistance device. And where this voltmeter need to be connected means it need to be connected only in the form of a cell. And what happens if the voltmeter is connected in a form of series? It will impact, that means what type of impact it is going to create means it will reduce the flow of current whenever you are connecting the voltmeter in a form of a series. So why it is happening like this? For example, let's take a circuit. So like this, if I connected means already this bulb is going to have some amount of resistance, as well as this voltmeter also is having a high resistance device. What will happen means the resistance will get added. That means the resistance will become increased. Yeah. So due to the increase in the resistance, the amount of current which is passing through the circuit will get decreased. Why? Because in the upcoming topic, we'll be learning a concept called as Ohm's law. V is equal to I into R, whereas R is equal to V by I. So from this relation, we can say that resistance is inversely proportional to the current. That means if resistance is high, current flow will get decrease. Current flow will get decrease. So because of this reason only, if you are connecting the voltmeter in the series, it will reduce the magnitude of current. Next, the numerical question. How much work is done? Work means we are going to calculate the value of W. Yeah, this one we are going to find out. In moving a charge of, what is the symbol of charge? Q. How much coulomb it is given? 2 coulomb. Across the 2 points, having a potential difference of V is equal to, how much volt is given? 12 volt. So what formula we can use over here? V is equal to W by Q. If we need W means, how the formula will rearrange? W is equal to V into Q. So W is equal to, what is the value of V? 12. And value of Q? 2. 12 into 2? 24. And what unit we are going to write over here? So work is equal to 24. Next question. Name the device that helps to maintain. By using what device you are maintaining? Cell R3. So by using what device you are going to maintain? Cell or battery. So the same question is like this. Name the device that helps to measure the potential difference. By using what device we can measure? Voltmeter. Don't forget. Measurements, it's by using what device you're going to measure? Voltmeter. And this voltmeter is a high resistance or low resistance device? High resistance device. And where this voltmeter need to be connected? Series or parallel? Parallel. Here. Parallel means end to end or common point? Common. So I'll connect the voltmeter. Just say which one is correct. Let's take 2 to 3 circuits. Plus, minus, plus, minus. Let's take this is option A. So out of these given three options, which one is correct? Either A, B, or C. A is correct. Why? It is connected. Even this also is connected in parallel, right? That's science. Positive is connected to the negative. That's a wrong representation. But over here, positive is connected to the positive, negative is connected to the negative. So the first thing we need to check whether it is connected in parallel or in series. If it is series, means directly can mark this is wrong. Next, after checking this one, check all the terminals whether it is connected plus plus or minus minus. Here minus is connected along with plus. So this is wrong. Over here minus to minus, plus to plus. Next.